In this video, we're going to look at inverse trig functions. We're going to focus first on how you graph those, and then second on how you evaluate those. So the three trig functions that we're going to look at are sine, cosine, and tangent. We're going to do the inverse of those three. We're not going to do the inverse of cosecant, secant, and cotangent. So to get the inverse graph, the first thing that you need to do is review what the regular sine, cosine, and tangent graph look like. So remember, with the sine graph, a full period goes from 0 to 2 pi. So these would be your tick marks. And remember, our highest point's 1, our lowest point's -1, and it starts on the midline, goes above, back to the midline, below, and then back to the midline. So this right here is your basic sine graph. Now, you should have learned in your previous math classes that for a function to have an inverse function, which is what we're finding here, it has to pass the horizontal line test. And if you look at the sine graph, it does not pass the horizontal line test. I can draw a horizontal line through it, and it's going to cross more than once, so it does not pass. So what we want to do here is we want to look at just a portion of the sine graph that would pass the horizontal line test. Now, if we narrowed the sine function down to these points right here, it would pass the test, but we've got this gap between the y-axis and when our graph starts. So rather than looking at that portion, what we do is we take our sine graph back a unit to -π², which means the next point would be down here. And what we do is we focus on just that portion of the graph. So I'm only looking at that portion that I've highlighted. Okay, if we're only looking there, that makes our domain -π² to π², and that makes our range -1 to +1. Okay, to get an inverse, remember that you just flip your x and y values and you flip your domain and range. Okay, so that's what we're going to do for this graph. I also wanted you to notice the different ways you can write the inverse function. You can write arc sine, that ARC in front means inverse, or you can do sine with the little -1, that means inverse. So just go ahead and get used to seeing both of those. All right, so when we draw our arc sine or our inverse sine graph out, we're going to reverse our x and y axis because our domain and range flip. So the x-axis, instead of running from -π² to π², is going to run from -1 to 1. Sorry, I did that backwards. -1 to 1. Let me erase that. And then our y-axis is going to run -π² to π². So this should actually be -π², and this would be +π². And you switch your coordinates. My first coordinate here is -π² -1. We're going to flip that and make it -1 -π². 0, 0 is going to stay 0, 0 even when we switch it. And then π²1 becomes 1 π². And so those are the 3 points we're going to plot. But when we plot them, our concavity has to change. Concavity means the way that your graph turns or curves. If you notice, this little piece right here has this kind of shape. It's kind of curved upward. We have to do the opposite and kind of curve it downward on our inverse graph. Then this piece right here that's slightly curved downward, we have to curve upward. And what you've done there is you've changed its concavity. So now our domain of the inverse function, domain is left to right, is -1 to 1. And the range is bottom to top, -π² to +π². Okay, let's look at cosine. Remember, our cosine graph has the same period as sine. It goes from 0 to 2 pi and 1 to -1, but it starts above the midline, and then it hits the midline, then it goes below, hits the midline, and goes back up. So here's our cosine graph. And if you'll notice, it doesn't pass the horizontal line test either. And whenever I say that about it passing the horizontal line test, that means it's a one-to-one function. Functions have to be one-to-one in order to have inverses that are also functions, okay? So when we're checking for the horizontal line test, we're checking to see if it's a one-to-one function. Okay, so this one does not pass the horizontal line test either. So what we're going to do is we're going to focus on just this piece of the cosine graph. If we only look there at the part that I have highlighted, it does pass. So looking at that part, our domain this time, left to right, is 0 to pi. And the range, bottom to top, is -1 to 1 again. And we're using brackets because we're actually hitting those values. Okay, so when we graph arc cosine or cosine inverse, our x-axis now is going to be -1 to 1, and our y-axis is going to be 0 to pi. So the top of my graph needs to be a little bit bigger than the bottom. Let me do it like this. Erase this part. Okay, so we said our x-axis is -1 to 1. Our y-axis is 0 to pi. So I'm going to put pi halves here and the pi up there. And let's reverse our points. This first point is 0, 1. So over here, it's going to be 1, 0. This point is pi halves 0. So we're going to switch it and it's going to be 0, pi. And then this one is pi -1. So we're going to go -1 pi. And it's going to look like that. We're going to change our concavity again. If you notice this part of your graph is kind of curved downward a little bit, that means our part up here is going to curve upward. This part is curved upward. This part is going to curve downward. All right, so the domain now is -1 to 1. And the range is 0 to pi. All right, now let's look at our tangent graph. If you remember from our tangent function, it had asymptotes at all of the intervals, or at pi halves and negative pi halves. So right here at pi halves, we had an asymptote. And at negative pi halves, we had an asymptote. And then in the middle, remember, we had a point at the center at 0, 0. And then here at pi fourths 1. And then at negative pi fourths -1, you had a point. And then it kind of has that cubic shape in between the asymptotes. Okay, so if we, and this one already does pass the horizontal line test if you're just looking at this one period. There's nowhere that I would draw a horizontal line here that it would cross my graph more than once if you're just looking at that one period. So we're just going to focus on that whole thing. So the domain of that is going to be from asymptote to asymptote, negative pi halves to pi halves. But this time, because we have asymptotes there, we don't include them. So it'd be parentheses instead of brackets. Negative pi halves to pi halves. And then the range is bottom to top. If you notice, we have an arrow on the bottom and an arrow on the top, which means our graph is going to continue forever in both directions. So our range is -infinity to infinity. Okay, so now let's draw the arctan, or the tan inverse graph. Okay, across the x-axis over here, it's going to be my y-axis values, which were 1 and -1. So -1 and 1. And then across the y-axis are going to be my x-axis values. So down here would be negative pi halves. Here we would have negative pi fourths, 0, and then pi fourths, and pi halves. Okay, on the original tangent graph, our asymptotes ran vertically. On the inverse, our asymptotes are going to run horizontally. So we're going to have an asymptote up here. I'm drawing with a pencil, so it's hard to see, so I'll put my dotted line slightly above where it really is. And then down here at negative pi halves, another asymptote. Okay, and then our graph in the middle, let's switch our points. Negative pi fourths, -1 becomes -1, negative pi fourths. 0, 0 stays at 0, 0. pi fourths 1 becomes 1 pi fourths. So those are our 3 dots, and our concavity changes again. So if you're looking at this bottom portion of tangent, it has a slight downward curve to it. So our bottom portion is going to have an upward curve to it. What I mean by upward is it's kind of, it looks like if we continued that around and made a U out of it, the U would have to be opening up, not opening down. All right, right here, this one has an upward curve to it. If I had a U, my U would have to be opening up. So here, I've got to make it have a downward curve to it. That doesn't mean my graph goes down. My graph is still rising, but it's got a downward curve to where if I had to draw a U out of that, the U would be upside down. That's the way you want to kind of think of the concavity. All right, so now my domain is negative infinity to infinity because I have an arrow left and an arrow right. And my range bottom to top is asymptote to asymptote, negative pi halves to pi halves. So notice on all of these that the domain and range flip-flop, which is what always happens with inverse functions. I'm not going to ask you to do any transformations of inverse functions. You just basically need to know how to graph these three, okay, by using the ones that you already know now. So you're going to use your basic sine, cosine, and tangent graph to graph its inverse by switching your points around. I think I'm going to do the evaluating in a separate video. What you do need to do is make sure you remember the domain and the range of these arc, sine, cosine, and tangent graphs.